Hi, this is Stuart, and today we're going to talk about best practices and exceptions. So let's start by talking about one of the things that makes exception handling in most programming languages, including the .NET languages, difficult. And that is the consequence of the early type design of exceptions. When the .NET team first started building .NET, they looked around at all the other programming languages. They realized they needed an exception mechanism. They hadn't really thought about some of the consequences. And so until people started using .NET in ways that were unexpected, which is a good thing because it means people are adopting your programming platform and doing lots of great things with it. But the fact that exception is a concrete type and that absolutely unhandleable exceptions by developers like Stack Overflow are mixed freely with application exceptions like invalid operation exception that potentially, right, we could handle. After a while, they wrote a really great book, and it's called Framework Design Guidelines. And they talked about this, and they talked about what they would do over, but they also talked about once you've done this, it's really hard to change because so many, probably hundreds of millions, if not more, lines of C# now depend on this exception behavior. And so it'd be really hard to change. But if you were starting a programming language from scratch, right, you might do something closer to this, where you'd say, okay, well, I have interfaces in my programming language, and interfaces allow me to specify abstract contracts. Tragically, they decided to add concrete implementations to those. I'm not wild about that feature, but I totally get how in some circumstances some development teams might like it. It makes me uncomfortable. I like interfaces to be abstract. And then they could have divided the world into I application exception and I fatal exception, or whatever, system exception, you can't handle a sever exception, you're doomed exception, whatever. And you might not be able to handle them, but in your stack dump or your crash dump, when your process gracelessly exits due to one of these fatal exceptions, you could at least see why. And then we derive application exception from my application exception. That would be really nice. And then, you could have an argument about whether or not that should be abstract or not. So if it's concrete, we could say catch. And it'd be just the same as saying catch exception, except that you'd only be catching the classes of exceptions you could handle. So it's a little better than catch exception in the current universe. But you could make the case that if we really want people, developers, right? Developers are people. I know this is strange to some of you, but it's true, that we ought to maybe force them to catch a very specific exception or a set of exceptions. And we'll see how that works a little later. So you could argue about this, but this is never, ever going to happen, at least unless there's a ground-up rewrite of C# on top of a new kind of runtime. And that runtime just starts from a clean slate. And they look back on all the things that were good and bad about .NET, and they go, okay, this is going to be, try number, 87. We're going to take what we learned and make some improvement. Let's be clear. I'm not being critical of the .NET team. They made some early decisions. They got it out into the world. People started using it. People started misusing it. And more importantly, not reading the instructions. And they ended up with what they ended up with. But if I had a time machine and I could go back and knock on Brad's office door and go, hey, sir, just can you spare me 3 minutes? And I'd whiteboard something for him, and he'd argue with me about it, and then I'd wander away happy, and then .NET 1.0 would have rolled out with something a little more malleable, but there's no such thing as a time machine. And so we got to work with what we have. So let's talk about the best practices for doing that. Rule number 1, and I see this one broken constantly, especially in library classes. Never catch an exception you're not prepared to handle locally. What is the role of the caller versus the callee? In other words, the library code. Well, the library code should be as resilient as possible. So if you are writing For example, a library that facades Redis or SQL Server or something else that is over there across a wire. What you probably want to do in the hindsight of 12-factor apps and what we've learned about enterprise applications and reliability and all that stuff is, man, it's great when those things have pluggable resiliency policies built in, and resiliency is the default. And then as a developer, you can then pass in an alternative policy or whatever and get the behavior that you need for your use case. Right? Inversion of control in the solid universe. And if we have things like .NET, we can use dependency injection, and that would be just great. If you have something connection-oriented, like say you're talking to SQL Server, and you get an error from the SQL Server or from the network that it's having trouble getting to the SQL Server, it's perfectly reasonable for you to catch that exception within the context of a resiliency policy block, a chunk of code, poly or, whatever. Entity framework has resiliency built into it just for that reason, so that you can make your context objects have resiliency by default. That's a good thing. But you should draw the line at vanishing exceptions. It's rare that you should what's called swallow, that is, completely catch and hide that an exception has even happened, and throw the resulting information about what happened away. So when you're designing a class that does something, you should ask yourself, where does my responsibility in this class stop and end? And you should make it clear from your class annotation, for example, what exceptions your class throws. You can use attributes, and you can attribute that. It says, listen, if I get into trouble, I'm going to throw this exception. And I'm going to throw, if I don't like your arguments, I'm going to throw these exceptions. And if I don't like your configuration, I'm going to throw those exceptions. And have that as part of the code to make your code self-documenting so it shows up in IntelliSense. And so that people, consumers of your library classes, your APIs, have a behavior, and you want that behavior to be consistent. So the first rule is never catch an error you're not prepared to handle locally. I've often seen code that is 5 or 6 or 7 or 20 calls deep, and in every single call there is a separate try catch. And what are they catching? They're catching exception. And they're not really doing anything with it except maybe logging it, which is another thing. Your library class may or may not need to have the responsibility of logging it. If so, then the logger should be dependency injected or, inversion of control into your code. And you should see if it is available. And if it is, you should use it. And if it isn't, you shouldn't. But you probably shouldn't do your own thing inside the library. I do mostly library code, so I care a lot about API. So here's kind of the first topmost anti-example that talks about that, right? We're trying and catching something and we're just rethrowing. Well, okay, we violated a couple rules here. The first rule is we're not going to make any attempt to handle the thing that went wrong. The second thing is I'm catching exception, which is generic as generic can be. The third thing is I'm throwing EX, which means I'm effectively throwing a new exception, which means that the old exception that I had on the catch line and its stack trace and all of its plenary history is gone. So if I just want to pass the exception up the stack, I should just throw semicolon, not throw EX. And we'll talk about enriching exceptions in a little bit. And so in this case, we really want to prefer that the caller decides to do with the exception. And so in your some stuff code, you could strip out all the exception handlers, write yourself a bunch of unit tests, and your unit tests may fail with an exception here and there. And when you find one of those exceptions, you explicitly make the test about that, and you go back and you attribute your method or your class to say this throws this exception in this use case. And you can read about what Microsoft says about this. I'm kind of building on top of what they said. If there's not an exception you need, make the exception you want, but do so correctly. The big mistake I see when people subclass exception to make their own exception is that they do not implement serialization correctly. And if you think about it, in a lot of our applications, we are probably going to have to pass that exception over the wire at some point to a logger. We're going to want to return it to the caller if it's a web API, or we're going to want to return it to our container host if we're running in Kubernetes or something. And so we really need to make sure that the extra stuff that we add to our exception to give it context, which is the value that we're adding by subclassing it, in addition to differentiating it from other exceptions with a custom exception name so that we can specifically catch our exception. And so you should also sand and spinach your exceptions with some standard prefix. Your project name is typically a good one, or your organization name. Be careful using organization name, though, because if your organization has lots and lots of pools of developers, and someday you go to share code and you've both implemented FUCO configuration exception, you're going to be sad. So you typically want to pick a name of sufficient granularity to disambiguate your stuff from other stuff, and that goes double for the namespaces that you wrap these classes in. Namespaces are important, and especially the bigger the project you're doing, the more critical they are. So in addition to writing our exception and testing its behavior, that in other words, that its custom properties are gotten and set, we're going to want to write a serialization test. And up on my GitHub, you can find a little helper that does that in one line. You say, I want you to go fill all the properties of this thing. I want you to serialize it, deserialize it, and compare all the properties. And that's what it does. So you can do a serialization test in a single line. But you should always test the serializability, because if you have custom properties in your exception and your serialization fails, you're going to have a loss of context for meaningful, useful things, right, when you pass it across the wire. And remember that passing across the wire includes just serializing it so you can write it to disk. So even if you're just logging to a file, the serialization's pretty much got to work if you want those bytes to end up on the disk. So serialization is not just for the wire. Everything in a computer is connected by wire. The only reason to wrap an exception is to enrich it. Here's the right way to wrap. I have a data processing exception, and the data processing exception is going to get thrown when my inner process in, say, a Saga workflow or something happens, and it's going to add a lot of extra context to the inner exception, which might be something horribly generic, like a serialization failure. That, okay, it's got some detail that might be useful, but it doesn't tell you where in the universe it happened. So in this case, it's always good if you're going to rethrow an exception. One, always make sure you're adding some additional attributes. Rarely just the new name of the exception is enough, but typically not. Typically there are other attributes you want to add, and that you always include the original exception as the inner exception, and of course that nests as deeply as you want. And of course, as always, we're going to write a serialization test for our exceptions because we're good developers. Don't catch exceptions just to log it. Again, if you're writing library code, right, there may be cases where your library is actually some sort of business process or Saga or workflow or whatever, right? And you're going to have lots of different steps and operations and branching and stuff like that. And there is a legitimate case for having logging, but that logging should be injected into your code and you should test to see if it's there. So you might have an override on your constructors for your class. It does business processing that takes iLogger factory or iLogger of T as an argument. And then everywhere in the code where you potentially may want to do some logging, you would say, logger ? Right? And if it isn't set, it won't log anything. And if it is set, it will. Don't catch exceptions just to log them, right? Because you're not logging something isn't handling it. Unless you're injecting a logger and there's an expectation that when you catch that exception, you're going to wrap the exception and add additional context to it and make the original exception the inner exception, like in the previous example, and log that and then throw, well, then that's probably okay. Logging the raw exception, you should have just let it propagate back up. And of course, if it was any kind of exception that you could anticipate, particularly if it either could have been handled or prevented by calling your library correctly, then you probably want to do the right thing and have the caller take responsibility. This is something of an anti-pattern. Don't do if branching in your exception. It may have been that there was a time where this might have been the only way to do it, where you had to check the type of each exception. But I'll point out that if you go look at books online for .NET, not only can you do the second example where we are catching the specific exceptions we want, and we can have as many catch blocks as our heart desires. And each we're handling the exception, and if we fall off the end, then there's an exception we hadn't planned on handling, right? We may handle it in the next version, or we may just go, wow, there's no way I could have handled that. Don't use if block and type magic. Use the built-in mechanism of having as many catch blocks as you require. And you always want to catch exceptions in the order of most specific to least specific. So if you have exceptions that exist in an inheritance tree, make sure that the blocks of the most specific exception, that is the lowest place in the tree, are caught, because it will catch the first one that's a good match. An aggregate exception is a sure sign you're using async wrong. Do you remember to pass in a cancellation token? Bet you didn't. Or if you did, you didn't use it right. Dot result, pure poison. Get awaiter, get result, turns your asynchronous call into a synchronous call. And you probably needed some more parameters besides that one. Async code should do async stuff. And notice that our thing is named async, as is the convention. And then just to provide a certain amount of compile time safe, and this goes for all class design. If you're going to support a generic, which is a good thing, generics are our friends, then use a where statement to make sure that the thing T, or any of the types that you're passing, conform to the contract and behavior you expect. So in this case, what are we saying? We're saying that this thing is newable and that the thing we're passing implements iStuff. And that way do some stuff async will cast it to iStuff, and then it knows that iStuff has certain members and certain operations, and it can go ahead and happily process whatever you passed, as long as T implements iStuff and it is newable. It supports an empty constructor without argument. Consider finally to clean up idisposable and unmanaged resources. So this may be a little bit of a journey, but follow along for just a second. So a using is a try finally in all but name. And you can see the structure of what really you end up that C# does it for you. The using statement is what the designers of .NET and the C# language call semantic sugar. So under the covers, it's going to generate some variation of that bottom piece of code, but golly, isn't the first thing a ton more readable? And so if your thing implements idisposable like 95% of the time, you want to wrap it in a using so that if it does throw an exception, why we're talking about this, right? If it does throw an exception, we can be guaranteed that our unmanaged allocation or our disposable thing gets disposed. That's important. Notice that in the lower example, I'm doing an old style, is the object actually initialized before I try to dispose it check. Obviously, using C#8, C#9, and so forth, you can now use the no coalescence operator, the question mark dot, and that is much more concise. And it's equally safe because that's what it's doing under the covers. Again, more semantic sugar to make your code more readable. I should just tell you that there is a small set of connection-oriented classes, particularly ones that use IP networking under the cover, that due to, again, some regrettable design and implementation choices that if they had to do it all over again, they would do differently, there are some things that are marked iDisposable that are not, in fact, safe to dispose because they either become holes in memory, that is to say, bits that will never get garbage collected, one of the downsides to garbage collectible libraries, or they do not, as in the case of the very best of the worst HTTP client, don't properly deallocate the operating system structures below it. And this doesn't show up on your small piece of code running a couple hundred operations an hour. And you're only connecting to a few things. And so this may never show up. But if you're running an enterprise or cloud app, and you're running a couple of hundred transactions a second, and you're allocating and deallocating HTTP clients, you can have your whole process and even your host crash and burn in the middle of your unit of work, losing your unit of work, which really bites. And you'll see something called SNAT exhaustion a lot of the time. And you've literally run the operating system out of available networking slot. And you can go Google SNAT exhaustion and read all about it. But this is the one C# thing that most enterprise developers use like candy. Although the problem was discovered 8 years ago, it's structural. And so we're unable to change the behavior of HTTP client in its newed up form, but there is such a thing as HTTP Client Factory, which I would encourage you to go read. And at this point, you're probably asking, but what does this have to do with exceptions? And I'll tell you, SNAT exceptions and the predecessor exceptions are all fatal exceptions. You cannot catch them, which makes this problem evilly hard to troubleshoot. So the way to avoid having to troubleshoot it is don't do it. Use HTTP Client Factory and learn about how to do it correctly by reading one of these or both of these articles. They're both excellent. And yes, some of them are a little old. And yes, this is still a problem. So just know that iDisposable and, good error handling, and particularly if you have a lot of iDisposable objects that you're not disposing, you're waiting for garbage collection to come and get by figuring out if they're out of scope or not. Two things are true. One is you're going to have your garbage collector work really hard, and it'll use up more and more of the resources on your host. So more CPU, more RAM, more whatever. So you want to be what my old instructor used to call parsimonious. If you have something that's allocated, you want to make sure it gets deallocated. And I even do that to like big strings or other big data structures. Even if they don't implement iDisposable, I'll set them to null so that the garbage collector will mark them for early collection. So I may have 20 more lines in my thing to go, but if I'm done with that chunk of memory, I try to null it out as quickly as I can. And obviously if it's disposable, I like to dispose it. Again, because these things are fatal system exceptions, you need to know about them and you need to understand iDisposable. And there's lots of good tutorials about that. And you need to make sure that the thing that you're disposing is safe. So Entity Framework Context Objects, yes. SQL Connection Objects, yes. Oracle ODP Objects, yes. The Redis Connection Client from Stack Exchange, absolutely. All those things implement iDisposable or pooling correctly, and which brings me to corollary rule about iDisposable things, and that is if there is a pool, use a pool, don't thwart the pool. And if in the instructions they say, by the way, create one of these objects and have it be a singleton, then have it be a singleton, whether you're using DI or not. There should only be one. If you have a factory that's handing you out stuff, it's almost always good to have it be a singleton. And if you read the documentation for whatever it is, it will tell you. So do pay attention. Consider the benefits of central error handling. So .NET has had central error handling since forever, since version 1.1, where, this object, app domain, current domain, and then you can have your own custom exception handler, which is very, very simple. It looks a lot like the one that you see in JavaScript or any other high-level programming language, and that is it tells you what through the exception, which is useful, and it also tells you what the exception and other interesting metadata is. So, in this case, if you want the exception e.exception is there, obviously you should probably check it for null first. But again, you'll find the question mark dot operator will come in, and you can have a generic handler. So if you have something that's not running in a web app, right, in a web context, if you have a function where you have a terminate and stay resident process, like a Windows service, or you have a Windows GUI, or you have a mobile app, or whatever, you can have a global error handler that is your last desperate catch-all. And generally speaking, if something makes it all the way up to the global error handler, your process is doomed. But that is not the case for web error, because they're going to have many callers. So depending on whether or not you have many callers, and just because this call failed doesn't mean that one should, and your process should gracefully exit, right? When you're writing a global error handler, you have to think about that. So there's a specific one for ASP.NET that works at the level of a filter on each request. And the great thing about that is that request A can explode, invoke the global exception filter. You can do whatever penultimate handling you need to do in there. And then your request, the next request over here, could succeed and not invoke this code. But be aware that global error handlers are a good practice, because they allow you to have a last chance, not always to handle the exception, but to make sure that the exception is properly documented. And you can take an awful lot of try-catch logging cruft out of your code by having global exception filter. Because if you have something that is truly unhandleable, you might as well let it bubble up to the very top and let the global exception handler decide whether or not the entire process is messed up or just this operation is messed up, and log and act accordingly. In the ASP.NET global error handler, for example, in my sample code, which you can go get off my GitHub, you will see that I actually do a switch statement on the type of exception, and I make sure that I'm always returning consistently the right kind of HTTP error code. So, for example, argument errors and type conversion errors and schema validation errors and type errors and things like that all return the appropriate 400 error. Security exceptions always return the correct 401 or 402. Not found exceptions always return the appropriate 404, and so on. So a global exception handler allows you to organize your exceptions, to format them, and in the case of connection-oriented protocol things, right, like a web service, you can say, I'm going to have a consistent set of behavior that's very easy to document and very easy for my consumers to use. So there's a ton of linters out there that are free or nearly free. And for every one of these, there's probably another set that are not free. But here are some of my favorites, including the built-in ones. If you're a Visual Studio user, especially a Visual Studio Professional Enterprise user, there's lots of nice linters built into there. And those little light bulbs and yellow triangles, they're trying to tell you things you want to know, things that will keep you from being woken up at 3 a.m. when your process crashes in production and your business users are unhappy. Don't let tech debt build up, and follow exception and other handling best practices, and you'll be a happy camper. My name is Stuart. Thank you for your kind attention.